8 years of experience now managing IoT devices. And so I'll cover basically going from prototype to production. So let me pull up my slide deck. I have about 800 slides and only 25 minutes to get through them all. So I'm going to talk fast. But it's like you said, Daniel, it's a casual conversation. By all means, if you have questions, just interrupt me as I go. I do not mind, not at all. Johan, good to see you from RAC, if I remember correctly. Yeah. I've got my RAC concentrator right there on my desk. So, let's do this. Share screen. Oh, actually, I'll tell you what else I have in hand.
Oh, nice.
Yeah, that's a good kit from RAC as well.
Wow. Nice pre-planned product placement.
You know what? He sent me a check in advance. So I was ready. He sent the bribe over, so I had got it received.
And if you want one of these, I can send you as well.
Yeah, Johan can mail them out. I got mine from Parsley.
And if the text looks very small for anyone looking at David's screen share, go ahead and hit the arrow buttons and you can make it full screen.
Yeah.
You don't have to do anything.
I was just going to say, yeah, wait a minute. What do I need to do? No. All right, so let's do this. Let's go ahead and get going here. You had informed me earlier, Daniel, that once I start the presentation, you can no longer see me. So that's good, because I did not, do my makeup and get dressed and get all ready for the day. But I figured I better throw a picture of myself in then. So here's me. I'm a developer advocate at Balena. 2021 events include FOSDEM, DockerCon, ARM Dev Summit, Datadog Dash, all virtual. I have not gotten on an airplane and gone to a conference in about 18 months at this point, but I don't know. I'm starting to think there might be some light at the end of the tunnel. We'll see. The very first thing that most folks ask is, who is Balena? And hey, we're in the IoT world. If you've ever used an etcher to flash an SD card or a USB stick, maybe flash Ubuntu or Fedora or something, Balena builds Etcher, and that's our open source image flashing utility. It gets literally millions of uses per month. It's pretty popular. Now, I know I've got a technical audience. You guys might just use DD, I'm not sure. But there's a lot of people out there that, hey, point, click, done, flashed. However, Etcher, we love it. It's an open source application. It flashes all day long, but it doesn't actually pay the bills. It doesn't keep the lights on around here. What does is Balena Cloud. Balena Cloud, you can see here, is a platform built to develop, deploy, and manage fleets of connected devices at scale. So that's what we're going to talk about here. This is certainly one implementation. I'll go through some best practices here. I'll show you how we do it in the Balena world, but you can take the information, you can take the knowledge. There are certainly other competitors out there. There's certainly, you can build your own system and solution, but at least just take this as a little bit of how we view it, and you can then use it to make informed decisions. So Balena Cloud is web-based control of IoT devices. We'll break it down into applications, devices, workloads. You can SSH to the devices no matter where they're located, or so long as they have some sort of connectivity. You can see logs streaming off the devices, container build information, and more. Container build information, the keyword there, container, is actually very important. There's two other pieces in the puzzle. So if you're using, for example, a Raspberry Pi, we don't actually provision devices with Raspbian. We build our own OS. It is also open source, called Balena OS. It's based upon Yocto Linux. So it's slimmed down. It is a minimal Linux environment. specifically targeting IoT devices. And Balena Engine, also open source, is based on Moby, which was the Docker contribution. So stream from us is Moby. And what do we mean by fleet management? Well, if you've got a Raspberry Pi or a Jetson Nano or a BeagleBone and it's sitting on your desk, that's great. It's easy to interface with. Hook up your keyboard, hook up your monitor, hook up your mouse, or connect to the UART pins and away you go. But once you have 100 devices or 1,000 devices or 10,000 devices, I don't know if Joello mentioned exactly how many devices they have under management, but suffice to say, it is a lot. If you have literally in the thousands, you need a way to manage and maintain those devices. And your fleet might not be all one type of device. You may segment out your workloads if you're doing some edge AI, if you're doing just some very simple environmental sensing at other locations, you might sort of mix and match your fleet as well. And once they are no longer on your desk and instead are in fact distributed all around the globe, you need a way to continue to, like I say, interface with and push workloads onto those devices. And so that's where Balena Cloud can help. You get this web dashboard, you can see the devices that are in your fleet. Okay, this is a pretty small one. I've only got 7 devices here. But point being, you can see their naming convention. You can see that they're online, what the type of device is. And then you can drill down into them and get a little more granular details and information. You can see the logs that are streaming off of this one here. This happened to be running a Datadog agent. You can see the containers that are on this particular device. There's 2 of them at the bottom left. There's a Datadog agent and Kerberos agent on it. But to come back around to what I really wanted to talk about and how it's easy to prototype and then move into production, let's kind of go through that workflow a little bit. So in the Balena world, you start off by adding a device. A device is a discrete, Pi or Jetson Nano. You can kind of see from the list. There's a lot of production class devices in here as well. People get started with Pis or Nanos or BeagleBones, but there's a lot of more enterprise grade things in the list as well. Some of those ones at the bottom, Verisite. I thought there was some Toradex hardware that was supported. Advantech is further up in the list. CompuLab. I'm trying to think who else is up. A few others. But anyways, there's about 65 or 70 devices that are supported out of the box. And like I said earlier, we build Balena OS for each of those. So you hit the blue download Balena OS button there. And once you have an image, of course, you then flash that to the SD card. Now, I've mentioned Docker a couple times. You go through the process of creating your Docker files. If you're familiar with Docker files, you can start writing your own. Got quite a few samples readily available as well, but here's a pretty simple one that I was showing off earlier. Is a little Datadog installation script. There is some tooling in place to build and push the containers onto the fleet, onto the, in my case, like I showed, 7 devices. You use a little Balena CLI. You can kind of see in that screenshot, it's Balena push, and then the name of the fleet. What it does is it takes your local artifacts, my Docker file, my other scripts or other bits and pieces that I need, and it sends them up to the cloud to be built. There's some Balena build servers that are essentially in charge of parsing the Docker file, building the container, and then distributing the container to all of the devices that are in the fleet. You can kind of see one going through the build process here. If you get to the end and you see a unicorn, you know you were successful. So that's how you know your build completed, and it'll get distributed out to the fleet.
Good to have that sophisticated quality control.
Yeah. If you see Charlie, you're in business. That's Charlie. And so you can kind of see then the orchestration is handled by Balena Cloud. Container got built. We saw Charlie, so you can see one here that is updating, and it'll download the workload, whatever it was that your Docker file, whatever you pushed. You can see, of course, the logs are coming off the device. We already talked about that. So that's pretty much it. I went through it in about 5-10 minutes there in practice, writing your Docker file, running your build, pushing it out to the device. I don't know, 10, 15 minutes, depending on what you're pushing out. We have a bunch of, sample repos, of course. And so that prototyping is pretty rapid. Okay, so you built a prototype IoT device. Simple as that. I literally just walked you through the process. That was it. So if you have a Raspberry Pi, you can do it yourself. I see the Amazon truck has arrived, so we might actually have a barking dog situation for just a moment here, so apologies if we get some barking dog. But, all right, so the next question is, how do you scale? I said, at the beginning here, we're going to talk from prototype to production. Well, scaling is actually really simple. So let's think about that workflow for a moment. We built a container, we loaded it onto a device, and there's and we can push the containers onto the device over the air, no matter where it's located. The containers are your workload, that is your application. We deployed to one device in that hypothetical scenario there, but we could have deployed to 1,000 or 10,000 or 100,000 devices. The same container is going to get distributed to all of the devices that are in the fleet. And you can manage and interact with the devices from the dashboard, as we saw. So really, you can prototype on cheap and available hardware and then go to production with some more enterprise-grade hardware. I have seen customers attempt to strap Raspberry Pis to the side of oil wells. I can tell you that they do not survive very long. An oil well is a very hot environment. They move. SD cards will, in fact, actually pop out of a Raspberry Pi when it is attached to an oil well. I have gotten inquiries from customers that would like to use Raspberry Pis in fracking. If you know anything about fracking, you know that that is an explosive process. You literally blow up the rock underground in order to release natural gas. I can tell you, it is not a good idea to try to send a Raspberry Pi into an explosive environment. But the point is this. Because it's a Docker container, and energy and industrial is not the only use case, of course. You heard from Joello earlier today also. But the premise here is that a container is going to run the same on any hardware underneath of it. So you can craft your container, as long as you know that that works, you can push it to any of the devices. The devices are going to show up in the dashboard, and you can push containers to entire fleets at a time. So scaling is actually really easy. Now, let me go back a slide. When I made this slide, you can prototype on cheap and available hardware. That was actually before this whole chip shortage thing. I've had this slide for a while. I don't know exactly how available Raspberry Pis even are at the moment, but point being, at least I know Jetsons, I've seen them still around. The big Pis, as opposed to the compute modules, are still pretty available, at least Pi 4s. But anyways, you can then go out to production with something a little more a little more enterprise ready. There's another sample fleet right there. That's a mixed one of Pis and Jetsons. That one was running some inferencing on the nanos and just some environmental sensing on the Pis. I kind of touched on this a little bit already, but hardware selection, again, going from prototype to production, and knowing that I've kind of covered the Balena methodology, but this goes for anyone. When you're going to production, trust me that device on the top left, that Raspberry Pi Zero that costs $5 without the GPIO headers, is very tempting. I get it. And they just released the Pi Zero 2, which is a little bit better, but it is still not going to survive very long out in the wild. It is not intended to. It was not designed for that. So in the middle, there's something there. It's called a Balena Fin. That's a carrier board for a Compute Module 3. Over on the right-hand side, that is an Advantech board. You can see that one's got far more advanced features on it, like CAN bus dual Ethernet, power via a barrel jack. I can see 2 MPCIe slots on that. So, you need to really, truly think about what is the workload that you're going to be running and where is the device going to be placed? What kind of connectivity is it going to have? Bottom row for Edge AI. On the left is a Jetson Nano. In the middle is a Google Coral tensor board. And on the right-hand side is an AGX. Again, you need to know specifically about your application. Be thinking about what are you going to be running? How much onboard AI processing is usually measured in trillions of operations per second tops. Are you going to be in need of? Is it going to be doing training or just running the model? And of course, TensorFlow versus CUDA, so you need to keep that in mind as well. Talked about this one already. Availability of hardware. There's a Pi 3. I took this screenshot just the other day. Next batch is expected in May of 2022. So if you are prototyping right now, be prepared to go to production in May of 2022, because that's when these will be back in stock, at least through Mouser. Certainly check other sources, and I know shipments are, always headed other places. But point being, from prototype to production, be aware of your selected hardware and its lead time. I didn't used to have to mention that when giving talks. Now I do. SD cards. We talked about these just for a brief moment. Here's another one where I promise you do not get the cheapest ones that you can find. SD cards do wear out. They die. They die all the time. Again, knowing that we have customers with thousands of devices in the field, I would make an argument to go to something more reliable like eMMC at the very least, just for onboard storage. If the device supports NVMe or something like SSD, far more reliable. But if you're going to use an SD card, make sure it is a high quality one. And I'm getting someone's mic. I don't know. Dan, you hear that?
I do. If you could mute yourself if you're not talking or asking a question, or kind of just mosey away from the group if you have to do a conversation.
Yeah, I don't know if you can administratively mute. You might have the ability. Last thing to cover is connectivity. How is the device going to be connected to the internet? Keep in mind where the device is going to live. I've seen customers that have, great, super fast 5G connectivity if you're sitting right in the heart of Silicon Valley, But I've also seen customers that deploy devices out into the middle of nowhere and sit on 4G, 3G, even 2G coverage. So you need to be cognizant of where is your device, the SIM cards that are included, are they going to work once the device ends in its... Yeah, it's all right. You know, Well, either way, it's fine now. And quite honestly, we are wrapping up anyway. Things to try out. There's hub.balena.io, which is sort of like it's brand new. It's just sort of gotten released within the past few months. It's kind of like an app store almost for IoT devices. You can just deploy projects right onto your device. Certainly the blog has plenty of material on there, and over on GitHub/Balena Labs, a lot of sample projects there. There's stuff with Edge Impulse, Jetsons, ROS, some signage and kiosks. Environmental sensing, of course, is pretty popular. Open Datacam is a neat one, does quantification using a nano. Basically, well, any Jetson device really. Basically allows you to track objects that cross a 2D plane. And that's it. I spoke longer than I expected. I'm sorry about that. I wanted to save more time for questions. But any questions? Did everything make sense?
And if you want to ask a question, you can just walk on up to the stage, sort of in between David and me, and speak directly into the mic.
Here we go. And I'm back. Well, if there were no questions, then that means that I, just covered all the material so well that it was all just so clear.
Yeah, I understand everything now. Well, what we might have is a case of some bashful souls, or don't want to ask public questions. And so, David, what we can do is we have a talk starting right at 1.
Sure.
That will be covering this whole plateau area. But if you were to step just to the left of the plateau over by the teleporter, you could hang out there for a little bit, and anyone who wanted to dive in a deeper one-on-one chat could come and say hello.
Hey, Patrick. Yeah, I can hear you. Go ahead. Yep. Well, that is a great question that I do not know the answer to.
And David, if you wouldn't mind repeating Patrick's question, because he's not broadcasting, so not everyone could hear him.
Okay. So Patrick asked why we have chosen Yocto versus Buildroot when building the OSs. Now, my immediate reply is, I do not know. It is a decision that predates me, and there has been some talk actually of switching. Buildroot is in fact one of the others that was under consideration. I've been at Balena for about 2 years, two and a half, and we were already using Yocto at that point. So I don't know, unfortunately, what the original decision or what the decision was. Way back when to go with Yocto. I will say that Yocto has been around, well, so has Buildroot for that matter, but has been around for a long time. I have to wonder if it had something to do with board support back at that time. Balena's been around 8 years. So I'm kind of wondering if they must have had earlier Raspberry Pi support. And again, that's a guess. But to be fair, yes, we've kind of had some discussions about whether Yocto, if that's the right path forward or not. So it has come up again.
Cool. Thanks, Patrick, for the question. Thank you, David, so much for the deep dive into Balena, the deep dive on how to get a prototype, how to deploy a prototype, when and when not to use a $5 Raspberry Pi.
Yeah.
This was a blast, and like I said, I'd propose for anyone who wants to chat with David, assuming you have a couple extra minutes.
Yeah, no, I do. Patrick, if you want to come cruise over to the left, we'll get away from the stage so that the next person can come up, and then we can head over there.
Cool. Well, thank you, David. Thanks everyone for joining us, and I hope you took good notes. We covered a lot of ground.
Thank you for having me, Daniel. Appreciate it.
Talk to you later.
Bye.
Check it out.